Welcome back to Physics Bundle. Today's lesson is Class 11 Uniform Motion. This is uniform motion. Uniform motion. Here, the first topic is mechanics. What is mechanics? It is a part of the science. It deals with the rest or motion of the particle of or an object. It's called the mechanics. Mechanics is divided into three parts. Number one is the statics. Number two is the kinematics. And number three is the dynamics. What is statics? For this, it is a study of the object at rest or in equilibrium under the various numbers of the forces. As we take a block on the floor, its weight acting in the downward direction perpendicular to the floor, mg, and the normal reactional force acting in the upward direction and perpendicular to the floor. So there is the two force, that is normal reactional force and the weight of the body. Though two of them acting on the object to keep it at the equilibrium position. This study is known as the statics. Now, what is the kinematics? What is kinematics? An object is moving. We study about the motion of the object, but not about for what reason the body is moving. It's called the kinematics. And the dynamics is slightly different from the kinematics, where we discuss about the motion of the object and also the reason for which it is moving. That is, if we consider a block or ball on the floor, we give the external force on the object or the ball, it will move. We discuss about the motion of the object or the ball and also the if external, that is external force applied on the body. It's called the dynamics. Now, let's move to the next topic. Rest and motion are relative to each other. Rest and motion are relative. What does it mean? When we are on the earth and standing here, we see an object at rest. We also see that object at rest. But when we go to the moon, what do we see? That the object is rotating with the earth. That is, it is moving. When we are on the same frame of reference, the object is at rest. We clearly observe that the object is at rest. But when we change our frame of reference to the moon, we see the object is moving. So the rest and motion of an object is relative. Now, moving to the next topic. Next topic is concept of point object. Concept of point object. When an object moving from A point to B point. Now observe that it is a broad object, but when it moves a longer distance, the diameter of that ball is negligible or the trivial in comparison to the path. So then this object considered as a point object. This is a point object. This is the point object. Now move to the next topic, motion in the 1, 2 and 3 dimension. Motion on the 1, 2 and 3 dimension. And 3 dimension. 1, 2 and 3 dimension. In the 1 dimension, one dimension motion, let us consider 3 axes individually. This is x axis, this is y axis, and this is the z axis. If an object moving along the x axis, an object moving along the y axis, and moving along the z axis. For the 3 different cases, we see that the object moving along the one axis, that kind of motion is called the one-dimensional motion. Next, move to the two-dimensional motion. Two-dimensional motion. In that case, we consider xy axis or yz axis or xz axis. In 3 cases, two axis forms a plane. If an object moving on that plane, it is called the two-dimensional motion. It is called two-dimensional motion. As the object moving on the plane created by the x-axis and y-axis, and next case y-axis, z-axis, and next case x-axis and z-axis. That kind of the motion is called the two-dimensional motion. Now, the three-dimensional motion. Three-dimensional motion. In that case, we consider the right-hand Cartesian coordinate system consisting by the 3 axes, so x, y, and z. X, y, and z. A flying on that 3D plane is called the three-dimensional motion because it consists the 3 axes. This is the x-axis, this is y-axis, and z-axis. That kind of motion is called the three-dimensional motion. In the one-dimensional motion, if a particle moving along the x-axis, its initial position is O and it moves to a point A, and let us consider that is x, 0. Now for the two-dimensional motion, is OX, OY, You can assume the yz, zx. This is the position of the particle and the coordinates of that point x comma y. And for the three-dimensional motion, we consider the three axes: x, y, and z. If the object situated at that point A, coordinates is x, y, z. Next topic is displacement and distance. Displacement and distance. Two are the physical quantities. We have already studied about that. Now we represent it in a different way. In one-dimensional motion. In one-dimensional motion. Let us consider the x-axis. Is O, x. A particle moving along the x-axis, its initial position is 0, 0. After time, it comes to a point A, whose coordinates are x, 0. Now it moves to the B point. Its coordinate is x2, 0. Now the distance covered by the particle, is x2 minus x1. This is the distance because it has the magnitude. Now, what is the displacement? Displacement is equals to, we are adding the direction, that is x2 minus x1 into I hat, because it is moving in the x direction. So this is the distance, this is the displacement. Now distance and displacement having the same unit in the SI unit, meter, and they having the same dimension, that is L. Dimension is L. And the SI unit of them is meter. Now this is distance is a scalar quantity, and displacement is a vector quantity. So clearly we understand what is distance and what is displacement. Now let us move to the two-dimensional motion. Two-dimensional motion. In that case, we consider the two axes. This is the x-axis, this is the y-axis. Point initially at the A point and moving to the B point. Let us consider its coordinates x1, y1, and that is x2, y2. Now measure the displacement. How to measure the displacement? Here we draw the perpendicular over the x-axis, and draw a perpendicular, let us A, B, C, D, and draw a perpendicular on the BC from A, that is E. Now we have to find the AB. How to find the AB? From D to C, this point is x1, 0, that is x2, 0. So that is x2 minus x1. So that should be x2 minus x1, and it is y2 minus y1. Now the displacement AB, now this is, if we add, this is the I hat and this is the J hat, that is, it turns into the vector, that is the two sides of a triangle. It is the resultant R. Now we can write from the vector addition rule, R vector is equals to x2 minus x1 I hat plus y2 minus y1 j hat, that is AB vector is equals to that. This is the displacement of the particle for that particular case. And what is the distance? Let us take the magnitude. AB vector magnitude is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square. That is the magnitude or the distance of the particle moving along the AB. Now let's move to the three-dimensional motion. Three-dimensional motion. Let us consider this is x-axis, y-axis and z-axis. Particles moving from the A point to B point. That is x1, y1, z1, and this is x2, y2, z2. Now let us draw a perpendicular. It will meet at that point. First we find the OAB, OCD, E. We have to find the CE. What will CE give us? CE will give us the former case as the x2 minus x1 I hat plus y2 minus y1 j hat. That is lying on the two-dimensional plane. Now let us move to the three-dimensional case, that is z2 minus z1. That is z2 minus z1. So for that, AB vector is equals to CE, that is AD, write it AD vector plus z2 minus z1 k hat. Now AD is equals to x2 minus x1 I hat plus y2 minus y1 j hat plus z2 minus z1 k hat. That is AB equals to. Now this will give us the displacement of the particle. And what is the magnitude? That is the distance. AB is equals to under root x2 minus x1 whole square plus y2 minus y1 whole square plus z2 minus z1 whole square. That will give the distance. Now let us move to the next topic, that is speed. What is speed? The rate of change of position of a particle with respect to time is known as speed. Now the formula of speed is equals to distance traveled by time taken. Here the distance is a scalar quantity, so speed should be a scalar quantity. Now what is the dimension of the speed? Dimension, distance is L and time is T, that is L T inverse. And the SI unit of speed is, distance is meter and time taken is second. Meter second inverse. Now the speed can be split into the two parts. Number one is the uniform speed, and number two is the variable speed. Variable speed. Now what is the uniform speed? Let us draw a straight line or the x-axis. If the particle moving the equal distance, let us consider the distance is, this is x, it is also x, and it is also x. Equal distance in equal time of interval. Equal time of interval is known as the uniform speed. Is known as the uniform speed. Now what is the variable speed? Second topic is variable speed. Variable speed. What does it mean? For the variable speed, unequal distances x1, x2 and x3, unequal distances and equal time of interval. Equal time of interval. It is variable speed. Or the equal distances, that is x, x and x, equal distances in unequal time of interval, t1, t2 and t3, or it may be unequal distances in unequal time of interval, and t3. That is the concept. Let us explain it. In the first case, if you consider a particle moving in 1 hour 20 km, moving next 1 hour 30 km, and moving the 40 km in next 1 hour, that is the variable speed. And as it is, now for the variable speed, we here consider the average speed. Average speed. Now for the average speed, we should sum up the all distances, divide upon the sum of the total time taken by the particle. That is, the average speed may be written as total distance by total time taken. Total distance by total time taken. So we may write it considering a one axis, one dimensional motion. This is O. Particle is at A point moving to the B point. So here the x1 comma 0, that is x2 comma 0, and here the time t1 and here the time t2. So the average speed is equals to x2 minus x1 by t2 minus t1. That is the distance traveled by time taken. It may be written as delta x by delta t. Now here, what is the instantaneous? instantaneous speed. What the instantaneous speed? Along the along the path of the motion, we should consider a point at which the speed we obtain is called the instantaneous speed. That is, instantaneous speed is the limiting value of average speed. So instantaneous speed is equals to limit of delta t tends to 0. That is delta x by delta t, and it should be written as dx by dt for the one-dimensional motion. For the three-dimensional motion, it can be written as, for three-dimensional motion, it can be written as dr by dt. dr by dt. Now, let us solve a numerical on the basis of the speed. The distance time equation of a particle given by x equals to 2t plus 3t square. Now find the speed of the particle along x-axis at time t equals to 2 seconds. How to find it? You know that the formula of the speed is v equals to dx by dt. Now d dt of 2t plus 3t square. Now differentiating them, 2 is a constant, so d dt of t plus 3 is a constant, so d dt of t square is equals to 2 plus 3 into 2 into t, that is equals to 2 plus 6t. Now at time t equals to 2 second, we have 2 plus 6 into 2, that is equals to 2 plus 12, that is equals to 14. So the speed of the particle is 14 meters second inverse, if x is in meter. Moving to the next topics in examination point of view, we write some knowledge points. Knowledge funda. Now for the knowledge funda, first we consider first case. If a particle travels with the speeds of v1, v2, v3 vn during the intervals of t1, t2 and t3, a particle moving with speeds with v1, v2, vn in the time intervals of t1, t2 tn. Now how to find the average speed? Find average speed. Now write the VAVG, that is a V average, equals to, we know that the total distance covered by the particle by total time of interval. Now here, if we multiply V1 into T1, that will give you the distance. Next plus V2 T2 plus Vn Tn, and divided by the total interval time, that is T1 plus T2 plus Tn. Now if we consider, that is in a numerical problem, if it is given T1 equals to T2 equals to dot 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 Tn equals to T, then we can write V average AVG is equals to V1 plus V2 plus dot 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 Vn into T, common out from the terms, and that should be written NT because there is a n times of the n numbers of the time intervals. So we have that is equals to V1 plus V2 plus dot 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 plus Vn by n. Now for the second knowledge funda, our channel is Fundu. Now second point, if the particle moving with velocity that is not speed, velocity by speed is v1 comma v2 comma dot 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 vn, then vn along the distances x1 comma x2 comma dot 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 xn. Now find the average speed. How to find the average speed? V average is equals to total distance. Here the total distance is x1 plus x2 plus dot 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 xn, and total time taken. How to find the time? If the distance is divided by the speed of the particle, we have the time. So first one is x1 by v1, second is x2 by v2 plus dot 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 xn by vn. Now if we consider that if we consider x1 equals to x2 equals to dot 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 xn is equals to x, then what will be the V average? V average is equals to, when x there is n number of paths and common the x, 1 by v1 plus 1 by v2 plus dot 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 1 by vn. So x cancel out, we have n by 1 by v1 plus 1 by v2 plus dot 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 1 by vn. Now to discuss about the velocity. What is the velocity? The rate of change of displacement with respect to time is known as the velocity. So here is right, the displacement by time. Now the displacement unit is meter and time is second, that is second inverse, and the dimension is L T inverse. Now the velocity of the two types, number one is the uniform velocity. For the uniform velocity, the equal displacement and equal interval of time is known as the uniform velocity. Now what is the variable velocity? Variable velocity. And how the velocity variable? If we change its magnitude, if it's change its direction, here keeping direction constant and keeping magnitude constant, or it may be change of both magnitude and direction is the cause of the variable velocity. Now, what is the variable velocity? An object is said to be moved with the variable velocity if it covers the equal displacement in unequal intervals of time, or unequal displacement in equal interval of time, however the small these intervals of the may be. So this is the variable velocity, and for the variable velocity there should be the average velocity. There should be the average velocity. Average velocity. Average velocity. Now, what is the average velocity? Average velocity is defined as the ratio of the displacement and the corresponding time interval. So, average velocity is, we can write that the displacement and corresponding time interval. Displacement and the ratio of the displacement and corresponding time interval. Corresponding time interval. Now here we draw the displacement time graph. So displacement time graph, OX, this is OY. Let us consider this is a graph. For that there is two position. Let us consider that is R1, T1, that is R2, T2. Now here we have that is R2 minus R1, and that is T2 minus T1. This is R2 minus R1, that is T2 minus T1. Now the average velocity V average is equals to R2 minus R1 by T2 minus T1. So we have, this is delta R by delta T, V average equals to. Now what is the instantaneous velocity? Instantaneous velocity corresponding to the limiting value of the V average. So V instantaneous is equals to limit delta T tends to 0, V average is equals to limit delta T tends to 0, delta R vector by delta T, that is equals to dr by dt. V instantaneous is dr by dt. Now take a question whether it is possible or not. Draw a graph of distance time. Distance time. Distance time. It is possible or not? It is not possible. Why it is not possible? At a definite time, a particle never be at two positions. So this graph is not possible. So the chapter is completed, and the next day numericals based on these chapters will be given. So thanks for the day.